Hello, my name is Zepeda and I'm the presenting author for the paper Towards Passive Working Environments, a free-running office in Guadalajara, Mexico. The problem statement or motivation for this work is the systematic increase of energy consumption for space cooling purposes in workspaces located in tropical locations, the decrease of application of environmental criteria for the design of workspaces, and the application of the contextualized energy-saving strategies outsourced from locations with different climates. The main objective of this work is to explore the climate potential for the application of passive strategies in free-running office buildings in the humid tropical climate of the city of Guadalajara, Mexico. Additionally, part of the objective is to analyze the climate and investigate the effectiveness of different passive strategies as means to create comfortable workspaces only relying in passive means to create and maintain indoor thermal comfort. The research considers existing precedents. The location of the work is the city of Guadalajara, Mexico, located in the tropical northern hemisphere, 1600 meters above the sea level. The location has an average yearly temperature of 18 degrees, with temperatures ranging between 35 and 0 degrees. The main cause of discomfort is overheating and therefore the excessive use of air conditioning during the year. Undercooling is not a problem because temperatures during the winter often exceed 20 degrees. The wind presence is almost permanent since the yearly average speed is 2 meters per second and there are only 45 hours without wind presence during the year. Rain is also copious and frequent during the year. A theoretical climate potential study shows that given the climate conditions of the location, passive strategies are efficient and possible. The most efficient are passive solar heating for the colder months, thermal mass for thermal storage during the year, and natural ventilation and night cooling for the warmest seasons. As a precedent, it was considered a free-running building designed by Studio Carmen Pinos. It was designed consider the application of passive strategies as well as an enhanced natural ventilation system. It is already built and habitated in the city where the research is developed. The dimensioning, orientation, materials, and morphology of the building were carefully designed with the objective of enhancing passive cooling strategies and the availability of adaptive opportunities. The identified strategies were solar protection visible in the double skin facade, thermal mass visible in the thick concrete walls, and enhanced natural ventilation with the possibility of cross ventilation and night cooling. In order to obtain a better understanding of the performance of the building, a digital building model was elaborated, recreating the internal and external conditions. The materials, resistance values, and internal gains were modeled, and a series of simulation runs were elaborated. The European standard EN 15251 was utilized to assess the environmental quality of the building interior conditions. The results of the simulations show that the building is capable of creating comfortable spaces according to the European standards, mainly as a result of the combination of passive strategies under these specific climate conditions. The overheating analysis showed that the interior conditions were never 3 degrees above the comfort limit and it never exceeded 3% of the occupancy time. The energy balance analysis showed that the shading device blocked most of the incoming radiation. Meanwhile, the thermal mass and the glazing area allowed to capture the night coolness and slowly release it during the day. Nevertheless, the original research question prevails. Why does the building work so well? Which is the most efficient passive strategy? With the objective of discovering that, a series of simulations were performed modifying 5 different variables. As a first step, 6 different alternatives of solar protection were tested, progressively changing. Then 3 different types of walls were tested, including a high thermal option with a concrete wall of 30 centimeters, a low thermal mass option of concrete of 15 centimeters, and an option of high thermal mass with 60 centimeters of insulation. Additionally, different interior heights of 2.7, 3, and 3.3 meters were tested together with 4 different options of window-to-wall radius with single glazing and double glazing options. At the end, 360 simulations were performed. After that, it was discovered that the passive strategy with the greatest influence is the solar protection, with the possibility of reducing the yearly overheating hours from 20 to 3%. The glazing material showed a greater influence than the wall composition, although the improvement with the glazing was only around 5%. Meanwhile, the wall types was only 1% regarding the percentage of timing comfort. Moreover, assuming the absence of solar protection, when testing the influence of the window-to-wall ratio and the interior height, the increase of the interior height did not show a significant improvement. There was only an improvement of around 3% when raising the interior height 60 centimeters. Meanwhile, a decrease of the grazing ratio showed a significant improvement, achieving a 95.7% of timing comfort with a window-to-floor ratio of 0.2. Conclusions: this study identified solar protection as the most efficient and effective passive strategy for naturally ventilated office buildings at the location. The application of a shading device allows the possibility of increasing the glazing ratio until desired daylight levels are reached. Another advantage of the consideration of a solar protection is the possibility of more window opening areas for natural ventilation. When the solar protection is omitted, the best performance is achieved with a high resistant envelope with a combination of thermal mass and insulation together with a low glazing ratio. Thank you.